Okay, let's take a look. So we were just doing NumPy. Now we're going back to kind of Python stuff. All right, this is kind of to align with the content that you guys are doing in your homework on Data Camp. So on Data Camp, I think there's homework that's due today. That, most of you guys have completed. That covered things like Lambda functions and defining your other functions and things like that. So anyway, I thought we would take a little bit of time and go through. Let me I'm going to go ahead and I'm going to clear the output, and we'll talk about all of these different things. Okay, so you can create something called a list comprehension. So this is one of the Python does a bunch of stuff, and some of the stuff allows you to kind of take shortcuts in your code, in that you don't have to write a separate loop to get a list. You can kind of write the loop inside the list itself, and then it'll produce a thing. Okay, and then we'll take a look at Lambda functions, which basically says you don't have to formally define a function. You can just write the function inside, in line, and it'll run. Okay, and so list comprehensions and Lambda functions kind of both follow in the theme of, let's just write something in line and save us a little bit of typing, right? And if you're not comfortable writing a list comprehension, no one's going to force you to use them. But they are a very popular feature of Python. And so, you might open someone else's code, and they will have things written as list comprehensions, and you've got to be able to read that and understand what's going on. Same thing with Lambda functions. If you don't like the idea of using a Lambda function, no one's going to force you to use it. But a lot of other people do use it. It's a feature of Python that is very popular, and so you got to get comfortable, at least with reading other people's code. And that's probably one of the best ways to learn, is to read other people's code. Okay, other people who are good reading their code. Okay, don't read a bunch of bad code. Right? It's just like, if you want to make movies or something, you've got to watch a bunch of good movies to know what a good movie looks like, right? I'm not going to be making any movies, but I like watching them. All right. So anyway, a list comprehension, it's basically like a little for loop, okay? And you say, the expression is what's going to be produced, and you say for values in whatever collection. So the collection could be a string. The collection most typically is a list, another list. And you just say, for the values in this collection. And then you can also apply a condition, like an if statement. And this list comprehension written this way is equivalent to writing code like this. Okay, for each value in a collection, if the condition, append the expression to your result. Okay, so these two things are equivalent. And I think once you get accustomed to reading list comprehensions, like, you'll read this and you'll pick it up very easily. It's a rather intuitive, in my opinion, once you get used to it, a rather intuitive way of writing out how lists should be constructed. Okay, so for example, let's make a list of the squares. Okay, so we're going to say the value we're going to produce is going to be x raised to the second power for each x in the range 1, 11, right? So 1, 11 is the integers 1 through 10. And so when we do this, it takes each x and it squares them, and it throws that into a list. And you get a list back like this. Okay? I think. Okay, and you can also so a list comprehension will make a list, and as always, you can always just throw that into a NumPy array as well. Okay. Okay. If you want to score only the odd numbers, you just add a condition, right? So this part's the same as before. X raised to the second power for x in range 1 through 11, and then you just throw in a condition if x mod 2 is equal to 1, okay? And that'll just do it for the odd numbers. Okay. Again, you know, the collection can be, so here I've had the collection being these range objects, okay? But the collection can be a list, in this case, a list of strings. And then so here, it's going to take the list of strings, and what is it going to do? It's going to take whatever that x is, okay? So in the first case, it'll be a, lowercase a, and it'll put in upper, and it'll, you know, put that in the list. But we have this condition, if length of x, okay? So length applied to a string is how many characters that string is. So it means if there's more than 2 characters in the string. So we run that, and so it skips a and as, and we get that, car, dove, and Python. Okay. All right, here is another list comprehension. This time my collection is a string. Okay, it says hello 963.257 world. Okay, and so what we're going to do is we are going to basically for each character in the string, that's what this part is, for x in string, says for each character in the string, if, and we run it through this condition, x is digit. So that's that can be applied to strings, and basically it'll say, you know, is this character a digit, 0 through 9? And if it is, the expression that we are going to store is convert that string into an integer. And we get, and it pulls out the digits that appeared in the string and stores them here. All right. I don't know. It's kind of neat. I don't know, or I think it's neat. You guys don't seem as impressed as I am, but that's okay. It's pretty cool. All right, thank you. That makes me feel better. Okay. All right, and then here we've got a dictionary, right? A, apple, B, banana, C, cookie. All right, so this is like the start of a great song. And for a dictionary, you can iterate over the dictionary. And so what do? We're going to do for d.items. Do you guys remember what d.items will return? So here it's so here's D, and so d.items is this dictionary view object which returns a list of tuples. Okay, so a list of tuples basically. Here, if I throw this into list, let's throw this into a list. So the view object. So here I've got a list of tuples. Oops, that's not what I want to do. And so for each tuple, okay, it's going to unpack them. A will go in as key, and apple will go in as the value. And the expression that we are storing is going to be basically take these strings and do A is for value, right? And so this is the expression that we are storing. And then we throw in a condition that if the key is not B, okay? And so we get A is for apple, C is for cookie. And so you can run this over a dictionary as well, right? So just recall what d.items, dictionary.items returns a list of tuples, okay? Yes?
In this case, you already had an object called D.
Yes.
So you have to always have an object which is iterable.
Yes, you always need some kind of object which is a collection, okay? So you could, we haven't really covered sets, okay? But sets are unordered, just values, okay? So dictionary is an unordered thing of key and value pairs. So you have some kind of collection, whether that's tuples, lists, dictionaries, strings, and then and it will iterate over each item in that collection. So it's always going to have a for blank, whatever it is, for x in the collection. Okay, and then it's going to store whatever the expression is. So whatever the expression is before the for. Okay. Okay. Are there any questions on that? Okay. And you can create a dictionary comprehension. Okay. And basically, you're going to have an expression for the key, an expression for the value, and then it will be for value in a collection if a condition. Okay, so here, in this first one, my collection is this list, and it says apple, mango, banana, cherry. And the values that we are going to create in our dictionary, the key will be the, so it's basically for f in fruits. So each fruit, so apple will our first f will be apple. So we're going to take f dot capitalize and make a key out of that. And then the value will be length of f. Okay, so how many letters are in that word. And so when we do that, we get a dictionary that says apple 5, mango 5, banana 6, and cherry 6. Yeah.
So I guess you can see more examples, but you're using the dictionary comprehension to primarily create dictionary.
Yes, so you are now creating a dictionary, which is basically key value pairs. So you need to have an expression for what's going to be the key, and an expression for what's going to be the value. This would be the, I don't know, the economy if the cost of items were based on how many letters are in its name. So what would be the most expensive fruit? Watermelon? I don't know. What? How many? I don't know. I don't know what fruits have long names. Okay. All right. Here we can take these strings, right? And I don't know if I explicitly defined what enumerate does. So let's here we'll let me just show you what enumerate does. So enumerate strings basically returns a bunch of tuples. Oops. So it produces an enumerate object, okay? But it creates a bunch of, basically a list of tuples or a collection of tuples where it's the index and its value, okay? And so enumerate produces a collection of tuples with index and value, okay? And so when we apply it to strings, we get 0a, 1 as, 2 bat, and things like that, okay? And then so, I mean, this is silly, but you can create a dictionary comprehension by saying, let's put the index over here and the value over here. So the key will become the index, and the value will become the value. And notice what we do is we say for, these two values in enumerate, okay? So this dictionary comprehension was just for each object f in fruits, but now that enumerate has tuples, we can unpack those tuples, and the index will be stored here as index, and value will be stored here, okay? And so, so when we do this, the 0 becomes the index, and a becomes the value. The 1 becomes the index, and as becomes the value. And here's almost the exact same thing, except when we unpack enumerate, we have index and value, but the way we are going to create our dictionary will be value : index. Okay, so the value becomes the key, and index becomes the value. All right, so what is this? This becomes a dictionary where you would look up A and it returns the index 0. You look up as and it returns the index 1. Okay, so so if I did index map A, what will this return?
0.
This will return a key error, right? Because it's going to say in the index map, there's nothing that has the key A, right? We have to put in something like 4, and it'll return the thing for 4, okay? So this will return an error. And likewise, if I do location map, or location mapping, and I do A, this will work, but if I give it the value 0, this gives me a key error. Okay, so you can only find things in the dictionary based on the keys that exist. Okay, you can't search for the values unless you create the dictionary values view object and then convert that to a list or something. Okay. Yes?
Can you combine like index map and your location map into the same dictionary?
Index map and location map into the same dictionary? Yeah, you can like add them together, right? Whoops. All right, so we can create a new dictionary. I'll just call this DD. And this will be index map plus location mapping. I don't know why. All right, and then I'll print DD. Oops. What am I doing wrong? Huh? If I just extend? I don't know if I can do this. All right, put me on the spot here. Okay, dictionary has no, let's see. Combining dictionaries. This is what we do. Look things up on Google. How to merge two dictionaries. I have two dictionaries, and what do we do? I have to use quargs. Okay. Yeah.
Can you? I think they mentioned. Maybe I'm wrong, but
yeah.
You can't use keys as values. So I guess if you're trying to.
Oh, but location mapping is one dictionary with string keys and integer values,
right.
And index mapping also has integer keys and string values. But there's nothing, they're both key and values. And it's true you can't swap keys and values, but over here it's still keys and values, and here it's just keys and values. It's just we've got different types here. So I think, how does this work? Let's see. Is this gonna work? This might not work. Well, it didn't kick back an error. Okay, so there we go. He's combined dictionaries with quargs. But to be covered later. So we haven't talked about quargs yet, but I guess that's how we can do it. Yeah.
I think you can also change it by using a function called update.
Update?
From dictionary.
Okay.
So
probably. Okay, so what do I do? Location mapping.
Yeah.
Dot update, and then
add in the dictionary that you want to.
And throw in the dictionary that I want.
And then it should be in location.
And it'll now be in location mapping.
Yeah.
Oh, look at that. That's amazing. Okay. Even better. All right. Use dictionary.update. All right, great. Thank you. Okay. And just be careful, though, because dictionary.update modifies the dictionary in place. Whereas this creates a separate dictionary entirely. So I don't want to run this right now. Okay, great. This is kind of like, maybe it feels a little out of place, but I wanted to just throw this in here. And you can prompt the user for input with the function input, okay? So here, I can just say name is equal to input, and whatever input comes in, you can so within Jupyter, it throws this thing, right? It opens up a little input field, and I can type in my name, and then now I feel special. So because it says hello, Miles, right? All right, that's great. Okay. Here, let me just kind of show you. So let's just do name is input again, okay? And then we'll print type input, okay? Or type name. And so whatever this is, okay, the input always comes in as a string, okay? So the input, so even though I typed in the number 123, it comes in as a string. All right, so this is a game that I just copied and pasted from a book called Invent Your Own Computer Games with Python. It's a fun book that kind of, like, you make tic-tac-toe and stuff like that. And I think it gives you some of the stuff. Okay, so here we'll just play a guessing game, all right? And so we'll start off with NumPy. We're going to start off and say guesses taken. There's 0 guesses taken. It's going to ask for your name, and then it's also going to randomly select a number from 1 through 20, and then it'll say hello, your name. I'm thinking of a number between 1 and 20. You have up to 6 guesses, and then it just runs a loop, okay? And because you get 6 guesses, you get, we're going to just range 0 through 6, okay? Or 0 through 5. And it'll say, take a guess. It asks for input for your guess. It'll convert it to an integer, right? Because guesses, the inputs are always strings, so we've got to convert that to an integer, which means if the user types in something that can't be converted to an integer, it's going to error out, okay? So we're not like doing anything to like stop the users from breaking your code. Okay, this is just a minimal thing. All right, and then we'll say if the guess is smaller than the number, we're going to print out your guess is too low, and if it's bigger, we're going to say your guess is too high. And otherwise, we will, and if it's equal to the number, we will exit the loop, and then guess if we exit the loop because the guess equals the number, we'll say, good job, your name, you guessed my number in guesses taken, guesses, right? And guesses taken is going to be, here, guesses taken starts off at 0 and goes up to 5, so we just have to add 1 to it, so it becomes the actual count, because we're indexing 0. And then if it reaches the end of the range object, meaning it reaches 5 and we didn't get it, okay, then it still stops the loop, and it'll say, basically, you got the thing wrong, right? Okay, so let's just try this out. Hello, what's your name? All right. Hello, hi, Miles. I'm thinking of a number between 1 and 20. Yes, okay, so let's, optimal strategy, right? We're going to start off with 10. Your guess is too low, right? So optimal strategy will be 15, because I'm really good at this game. And okay, so then next we've got 18. All right, and then so now I have to do 16 or 17, and it's a toss-up. All right, I got it, 17, and I got it in 4 guesses, right? So if you play it correctly, you can always win the game within Six guesses. Okay. But anyway, so.
Is there a reason it's 6 guesses, or
Because, see, what is.
there's some math reason?
No, you just 20 divided by 2 will be 10, and then divided by 2 will be 5, and you keep splitting, and you just have to get these guesses out of the way, right? So 10 or 11 would have been an optimal guess for the first guess, but because you have 1 through 9 left over, and then 11 through 20 on the other side. So okay, anyway, that's that. We can play again. It's not that hard, right? All right. And then, so if I do bad, right? If I do 1, 2, 3, 4, 5, 6, I lose. Okay. All right. That's wasn't that a fun game? All right. So anyway, you can make little games this way by asking for inputs. Okay. This is our favorite topic, scope, right? In Python with functions. Okay, and so if Python can't find a variable in the function's body, it will search the next higher scope, okay, which is basically each function has a parent, which is where the function is defined. So if it's defined in the global environment, its parent is the global environment. If the function is defined inside another function, then its parent is the other function. And then the other part is variables inside functions only exist inside the function, okay? And you don't have access to it from the outside world. So here we're going to define x, y, and z as 1, 1, 1, 1, okay? So this is a tuple, and we unpack it, and x gets 1, y gets 1, and z gets 1, right? I don't have to write x is 1, comma, y is 1, semicolon, z is 1, all right? I can just do this. That's nice, all right? So we're going to define f, and then here inside f, I define y as 2, and then I say return the tuple x, y, z, and then we print out f. Okay, so we call f right here, and so y will take on the value 2, but then if we ask what is x, y, z in the global environment, those remain 1, 1, 1, okay? So changing y to 2 only affects the value inside the function. Okay, and then when we ask it to return x and z, which are not defined inside the function, it checks the global environment and finds x and z there. All right, so here I'm defining a function f, and inside f I say y is equal to 2, and inside f I also define a function g where I say z is equal to 3. Okay, and so now. And then g is going to return the values x, y, and z. And f will return whatever g returns. So when I call f, in the global environment, we have 1, 1, 1. Okay. Inside f, I assign y to 2. And then I ask to return g. And so g is defined inside f. And it assigns 3 to the value z. And so it's going to return x, which it doesn't find anywhere and uses the global value. Y, it checks the higher scope and it's going to find 2. And z, it's got its own value right here. And so it's going to get the values 1, 2, and 3 for x, y, z. Okay? But again, if we ask for the global environment values of x, y, and z, we have 1, 1, and 1. Okay? This is very similar. So inside G, so I define G inside the global environment, and I define F inside the global environment, okay? So if you look at the structure of F, it still has the same 2 lines, y is equal to 2 and return G, okay? And it's just that we've moved the definition of G outside of F into the global environment. And G has the same definition. Z is 3, and return X, Y, Z. Okay, so X, Y, Z in the global environment are 1, 1, 1. We've defined G here, and we've defined F here. Okay, we're going to call F. We say print what F does. Okay, so inside F, we get Y is 2, and then we ask it to return G. So then we run G, and inside G, we have Z equal to 3, but we don't have any values for X and Y. So where is it going to search for X and Y? It's going to search in the global environment, and it's going to find X is 1 and Y is 1. Okay, and again, those values don't affect the global environment. So we have 1, 1, and 3, and 1, 1, 1. So the difference, please pay attention and understand the difference between this box and this box. Because G is defined inside F, when it can't find Y, it uses the value inside of F. And because G is defined inside the global environment, when it can't find Y, it uses the value in the global environment. Okay. You can have a keyword global. Okay. Keyword global gives the function access to the value in the global environment. Okay, and so what happens here, we've got X, Y, and Z defined as 1 in the global environment. We have F, where we modify, we assign the value 2 to Y, and inside F, we define a function G, and we call global Z, okay? And this tells Python, whenever we see the variable Z, we're talking about the global environment variable Z. So this value, this line, 3 equals Z, will assign 3 to the global variable Z. Okay, return X, Y, and Z. And so Z, it's going to find Z is 3 in the global environment. Y, it searches its higher scope, which is F, and it's going to be 2. And X, it will use the global environment, and it'll be 1. Okay, so printing F will return 1, 2, and 3. But then printing X, Y, and Z, what will be the values of X, Y, and Z in the global environment? X is 1, Y is 1, and Z is 3. Okay, so print F will return 1, 2, 3, because this, when it can't find Y here, it uses a higher scope here, and it uses this value of Y. But then the Z is the global Z. Okay, so we have 1, 2, 3 when we ask for F, and when we ask for X, Y, and Z, we get 1, 1, and 3. Okay, and all right, so here I've got X, Y, Z is 1, 1, 1 again. Inside G, I say Z is 3, and we're going to return X, Y, Z. And F, we have global Y, Y is 2, and we return G. Okay. So when I say print G, it uses the global values of X and Y and its local value of Z, okay? And the local value of Z doesn't affect the global value. So I have 1, 1, 3, 1, 1, 1, okay? And even though I have global Y and Y equals 2 written here, F has not been called. So this assignment of 2 to Y has not been executed yet, okay? So when I call F, okay, when I say print F, it's going to call F, and it's going to execute this line. It's going to say, all right, use the global Y and change its value to 2. Now run G. Okay, and then when it runs G, we're going to have Z locally assigned the value 3. And then it's going to search for X, and it goes to its parent scope, the global, 1. It searches for Y, which has now been modified to 2 because F has been called. And then Z, it's going to use its local value of 3. Okay, so print F will go 1, 2, 3, and then when we ask for the global values of X, Y, and Z, we have 1, 2, 1 because calling F has modified the global value of Y. Yeah?
And if you don't want to, you'd only not use global if you don't want to modify the global value.
Right. You only use the keyword global if you want the actions on this variable to change the variable in the global environment. Okay? If I don't define y here, okay? So even though I haven't defined a y here, okay? When I call global, wait, is this right? Oh, no. Yeah, this, no, I would get a binding error. So let me, I'll get like basically this object is not defined. So let me just use a different thing here. But okay, well, let me just run this. Here, let me just, what are some letters I haven't used? P, elemental P, Q, R, S. Okay, so we're going to have P and Q equal 1 and 1, okay, or 1 and 1, and then, and I'll say define F, and inside F I'm going to say global S. Okay, and then I'm going to assign S to the value 2, and then it'll return the tuple P, Q, I guess should have been R, but whatever, S. Okay. And then if I call F, did that work?
Yeah, I think it creates S in the global.
It creates S?
Yeah.
Oh, yeah. I'm sorry. This, okay, sorry. This will create S in the global. Okay. It's non-local where it's gonna do the other thing. Okay, sorry. Okay, that's fine. Okay, and then over here, just another example: XYZ 111 global Y. We get change the value to 4, and then when G runs, we're giving access to global Y and global Z, and we modify those values, and we return that, and then so we get this, right? And so this, even though we changed the value to 4, because we executed G, it overwrites this value in the global. Okay, non-local. The keyword non-local will search the higher scope for the variable, okay? And we'll modify it, okay? So here I've got XYZ is 111, Y inside F is 4, and non-local Y will give access to this value of Y, okay? Because G isn't defined inside of F, and so non-local Y will modify this value of Y to 10, okay? Whereas global Z will modify the global value of Z. Okay, and within that, we say print XYZ, okay? So when I call F, it has Y equals 4, and it defines the function G but doesn't run it, and then it prints XYZ. So we get 1, 4, 1, because X is 1, Y is defined 4 locally, and Z is 1 in the global environment. And then it calls G, and when it calls G, it modifies the value inside F to be 10. And so we're going to get 1, 10, 3. And then when we ask what are the values in the global environment X, Y, and Z, only the global value of Z has been changed to 3. Let's try P and Q again, be 1 and 1, and then I don't think R exists right now.
No, there's not.
Let me just check. Okay, so R doesn't exist. So we're okay here. And then so if I define F, and then I say non-local R, and we're going to do R equals 2, and then we'll print PQR, or we'll just return this as a tuple, okay? And we call F. This gives me an error because it says no binding for a non-local R found, because there's no R in the global environment, okay? So we'll return an error because R does not exist in the non-local environment. Oh man, it's already 3:48. Okay. So here's some cool stuff, all right? So Python functions are objects themselves, okay? So here I've got this list of strings, and it's just like crazy formatted, okay? So I've got Alabama with a whole bunch of spaces, Georgia with exclamation points, South Carolina with 2 spaces here, and some hash marks, and West Virginia with a question mark, okay? And Florida is all capitalized funny, all right? Let's say we want to clean these up by applying a series of functions, okay? And we can write a function to do this. And we want to first strip the white space. We're going to use regular expressions to substitute any either question mark, hash, or exclamation point with no character. We just remove those. So that's the substitute. And then we turn them into title case, okay? And we can do this. And then so we define a function clean strings, and when we run that, our strings get cleaned up, okay? It's much nicer this way, right? Okay, what I can also do is I can define a function called remove punctuation, which does the remove punctuation, and then I can create a list of operations, okay? So here we're gonna say apply, the first operation is gonna be string.strip, and string.strip removes the white space. So if I've got Alabama written like this, it just removes the white space in the before and end. Okay, remove punctuation removes punctuation, and string.title will put things into title case. Okay, and look what I have here, okay? I define a new function, cleanStrings2, which takes in 2 arguments, strings and operations. And we're going to run the loop over each value in strings, so that's going to be for each of these funnily written state names. Then we're going to run for each function in the operations list, and it's going to say the value is going to be apply the function to the value. So it's going to do string strip applied to the first thing, and then it's going to go to the next function in the list, and it'll do remove punctuation applied to the value, and then it'll do the last function here, string.title, and throw that in here, okay? And so now that I have this, I can call cleanStrings2 on the states and cleanops, okay? And then you can give it a different list of functions. So here I'm going to do string.strip, remove punctuation, string.upper, okay? And then I throw in a Lambda function, which we're running out of time to explain, but this is just like a replace, if you see 2 spaces, replace it with 1 space, and we do that, and now we get all caps and stuff like that, okay? So that's kind of neat. And basically, there's the map function, which is much like the apply function in R. It returns a map object, and if you want to see the contents of it, you can throw it inside a list, okay? I guess we'll have to talk about Lambda functions later, but anyway, this is just some neat stuff here. Okay, we'll end here.